Welcome to this course on deploying Spring microservices to AWS with Elastic Container Service ECS and AWS Fargate. I am Rangarao Karnam. I have more than 20 years of application development experience with a variety of languages like Java, Python, JavaScript, and a variety of frameworks, REST API frameworks like Spring Boot and front-end frameworks like Angular, React, and Vue. I am also an AWS certified solution architect. At in 28 minutes, we ask ourselves one question every day. How do we create more amazing course experiences? The success on a wide variety of platforms, including Udemy, with more than 200,000 learners, is a result of this pursuit of excellence. We love programming and we believe cloud offers enormous potential to programmers and enterprises. We believe cloud is among the top skills to acquire for Java developers today. In this awesome course, we will help you get started with Amazon Web Services. We'll deploy a variety of Java Spring Boot applications, Spring Boot microservices using AWS Elastic Container Service ECS Fargate. Microservices is a complex world and containers makes it easy to deploy microservices. However, deploying containers to the cloud is not very easy. AWS Fargate makes it very easy to deploy and manage containers in the cloud. In this course, we'll be using a number of microservices, a Hello World microservice. We'll be using a couple of microservices called the currency exchange and the currency conversion microservices. We will build container images out of all these microservices. We would deploy them to a container registry like Docker Hub, and we would actually deploy all of these to AWS using AWS Elastic Container Service as well as AWS Fargate. During this course, you will learn the basics of Amazon Web Services. The focus of this course is on deploying Docker-based Spring Boot microservices to AWS. You will learn the basics of AWS ECS, that is Elastic Container Service. We will use ECS with EC2 as well as with AWS Fargate. You will learn how to create multiple instances of the same application and how to load balance between them, creating load balancers. You will also learn how to auto scale instances based on the load. We will talk about a couple of important microservices features, service discovery and centralized configuration. We'll implement distributed tracing with AWS X-Ray, and we'll also implement a service mesh with AWS App Mesh. We expect you to be familiar with Java and some familiarity with Spring, Spring Boot and JPA, and building REST API with them would be awesome. To do this course, you would need an AWS account, to create which you need a valid debit or a credit card. We'll help you install all the tools that you need for this specific course. The complete source code for this course, including step-by-step details, is present on the GitHub repository of this specific course. What are you waiting for? Let's have some fun deploying Spring microservices to AWS. We had a lot of fun creating this course, and be assured you'll have a lot of fun too. If you want to learn more, go ahead and click the enroll button, or you can take a test drive using the free preview feature. Good luck, and I'll see you in the course. Welcome back. In this video, let's get quickly started with the course. First of all, let me congratulate you for making a great choice. Now, let's get started. One of the first things that you need to do is to make sure that you bookmark the GitHub repository of the course. It would be awesome if you can star and fork it as well. The GitHub repository of this course is github.com/in28minutes/deploy Spring microservices to AWS ECS Fargate. You can also find the link to the GitHub repository in the resources section of this specific video. This GitHub repository contains the source code for all the projects that we'll be using in this course. In this course, we would assume that you have a little bit of familiarity with Docker, Spring, Spring Boot, JPA, and Hibernate. However, if you don't really have that experience, you can quickly watch these videos: Docker in 5 steps, Spring in 10 steps, Spring Boot in 10 steps, JPA Hibernate in 10 steps, and get started with those specific tools. The thing is, you don't really need to watch all these videos right now. What we'll do is when we get to a specific section of the course, we will highlight what are the videos which might be important for you. And at that time, you might want to go and watch that specific video. If you scroll a little bit down, you would see all the container images that we would be building and using during this course. All these are deployed to Docker Hub, and we will deploy all these either to AWS ECS or AWS Fargate. Some of the details related to the microservices are also present in here. If you scroll a little down, you would end up on the installation guides. This playlist contains 3 videos which would help you to install Java and Eclipse and test your embedded Maven, which comes up with Eclipse. If you don't have Java installed or Eclipse installed, I would recommend you to follow these guides and install the right version of Java and Eclipse. Any version of Java greater than 8 should be fine, and any of the latest versions of Eclipse should be cool. Each of these projects also contain a lot of details about them. So you can see how to run that particular project, how to build a container, all the instructions which should be used, all the resources which are exposed, and all the details are also present on that specific project's README page. Okay, I understand. I've already bored you enough with a lot of details. The most important thing is to make sure that you have at least Java 8 and a latest version of Eclipse installed. And I'll see you in the next step. Until then, bye-bye. Welcome back. Are you excited to get onto the cloud? I am very excited to get you on your journey towards cloud. And the first step is to create an AWS account. You need to go to your website aws.amazon.com. To be able to create an AWS account, you'd need 2 things. One is your personal details, including your address. The second one is a valid debit or a credit card. Even though we are going to use free account for most part of these courses, Amazon needs your credit card or debit card details. So go ahead, have them handy, and click the create an AWS account link. You can also click the create a free account, or if you don't see those buttons, you can click something on the my account as well. And you'd land up on a screen like this. Over here, you need to enter the email address that you'd want to use with your AWS account, and you'd want to give a password for your AWS account and confirm the password as well. You can also give a account name for your AWS account. So I've entered the email address, passwords, and also the account name we would want to use. Once you are done, you can go ahead and click the continue button. Once you click the continue button, you should see a contact information page. You can either create a professional account which is associated with an organization, a company, or a personal account which is associated with a person. I would choose a personal account and enter my personal details in here. You need to enter your name, your phone number, choose your country, and enter your address as well as your city, state, and your postal code. Make sure that you are giving your real details, and also give a valid mobile number because Amazon would use that to verify. Once you have entered all the details, you can check this button to ensure that you are agreeing to all AWS policies. You can click that and read through and make sure that you are fine with it. You can now go ahead and click create account and continue. The next screen you would see is a payment information screen where Amazon asks you for your credit debit card details. One of the important things to understand is also the fact that Amazon will not charge you unless you exceed the free tier limits. You can get more information about what is in the free tier by clicking this link. You can also read the frequently asked questions. So go ahead, understand what you are getting into, and once you are comfortable, go ahead and enter your details in here. You'll also need to enter your billing address. Once you have entered all the details, go ahead and click the secure submit button. There might be additional screens you would see to make sure that your bank transaction goes perfectly and Amazon is able to do a transaction with your account. Once your bank transaction goes through successfully, Amazon would ask you to confirm your identity. It is done by verifying your phone number. So enter your details and click contact me. Once I click contact me, a screen with a pin would be shown to you. Amazon would call you and you need to enter whatever you see on the screen on your phone. A few times, AWS might send you a verification code and ask you to enter it on the screen.
I know it's kind of boring process. The initial sign up to get onto the cloud is little boring. Amazon is giving you access to very powerful servers, and they want to be really sure who you are, and they have a way to reach you in case there's a problem. That's the reason why the sign up process is a little tricky. Once you're verified, you can go ahead and click the continue. We will go with a free tier plan. That's the one which we'll choose on the next screen. On the next screen, you can personalize your experience by selecting a role and also selecting an area you are interested in. I would actually close this out and click complete sign up. Now I can actually sign into the console by clicking the sign into the console in here, or clicking my account and going to AWS Management Console. So I'll say sign into the console. You would be taken to a screen where you can enter your email address and enter your password and click sign in. Once you do that, you're logged into AWS. That's cool, that's great. You now have an AWS account, and let's play with it a lot more in the next step. In this step, we created our AWS account. I know it was a kind of a boring process, but this is just a one-time activity that we do, and it should not be a problem for us going forward. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we created our AWS account. In this step, let's make our AWS account more secure. Let's learn about something called IAM, and let's learn how to create a IAM user and how to use an IAM user for all our AWS activities. When we first created our AWS account, the email ID and the password we used to create is what is called the root user. The root user can be used both for the console access as well as programmatic access to the application. The root user has complete access to everything within your AWS account. He can even close your AWS account. So it is strongly recommended not to use the root user for your day-to-day activities. Even for the administrative activities, it is better to create a different set of users called the IAM users, Identity and Access Management users. So the only thing you should be doing with your root user is to first create an IAM user and log down the credentials somewhere secure. Let's learn how to create a IAM user next. Let's get started now. I'm already logged into the AWS console. How do we get into the AWS console? You can go to aws.amazon.com and sign into console. Since I am already logged in, it directly takes me into the account. Let's go to services and type in IAM. When I type in IAM, you would see that it says IAM and manage user access and encryption keys. I'll click this. Let's go to IAM. IAM is used to create AWS users, assign them to groups, and also assign what permissions they have. In AWS, if I want to assign a permission to a specific user, there are two ways I can do that. One is directly assign a policy to him, directly assign a permission to him. The other way is to create a group, assign the permissions to a group, assign the policy to a group, and make the user a part of that group. What we'll do now is take the second approach. We'll create a group and we'll assign a user to that specific group. So let's get started. Let's start with creating a new group. I'll call this developers. So I'll create a group called developers. Next step, I'll now need to give these developers access. So what can these developers do? How can I do that? In AWS, we have to attach policies. There are a number of predefined policies which are present in here. These are called managed policies, and these are managed by AWS. For now, I'll give all developers administrator access. You can also give them access to billing. You can, for example, AWS Lambda is one of the services, so you can give full access to AWS Lambda. What I'll do is I'll take a shortcut for now and I'll just give administrator access so they get access to everything. Now I'll say next step, and now I can create the group. Now we have a group. Now I would want to actually go back. So dashboard, we have a group. What do you need to do now? we need to create a user. How do we create a user? What we are doing in here is creating a user for our AWS account. I'll say add user. On this screen, you can enter the ID you would want for that specific user. I'll say in 28 minutes underscore dev. As you can see here, you can create multiple users at the same time with similar kind of accesses. But let's stick with one user for now. Next thing you can select is the AWS access type. Now, what is access type? Typically, whenever we talk about performing actions, there are two types of users. One is people who would want to actually log in, use the UI, and perform actions. The other kind of users might be programs. So you want to write a program to create some resource in AWS. So that's why there are two kinds of accesses which are present: programmatic access and AWS Management Console access. What we are doing now is using the AWS Management Console access. We use the AWS root account, logged in, and we are manually going through the screens and doing all the action. So what I'm doing is I'm giving AWS Management Console access to this user. So this user would be able to log in with his user ID and password and do exactly what we are doing in here. So he'll be able to log into console and perform all the actions. I'll also provide programmatic access to this user. What does programmatic access allow? For example, if you have a command line tool, AWS CLI. AWS CLI is a command line tool where you can run commands and do things with AWS. And when you want to use AWS CLI, you would want to use programmatic access. And there, this kind of access type will be really useful. We'll talk about programmatic access a little later. For now, the important thing is the fact that we are giving this user both types of access. So you can use this user credentials for logging into AWS Management Console as well as through a programmatic means. And let's use custom password. So I would want to assign a specific password. You can also use auto-generated password, but let's go with custom. And what we can also do is to have the user create a new password when he tries to sign in. For me, that's not important, so I'll uncheck that and let's click next. The next thing is to assign a group. So I'll assign a group of developers for this specific user. You can assign multiple groups. Here we have only one group, so let's assign just that. Let's not worry about tags for now. Let's go to the review screen where we can see the fact that we are creating a user called in 28 minutes underscore dev. We are providing him programmatic and AWS Management Console access, and we are assigning him to a group of developers. And let's go ahead and create user. So what you would see now is a success screen. So you'd see that we have created a user successfully. Now I would want to log in with this specific user credentials. Can I go to aws.amazon.com and use that URL to sign in with IAM user credentials which we created just now? The answer is no. The important thing you need to remember is from now on, to log in into your account, into your AWS account as an IAM user, you need to use this URL. So I've taken this URL, copied it, I'll log out. So I'm signing out of my account and I'm pasting the URL which we have copied. So let's paste that in. I would go ahead and enter my user ID and password and sign in. And now you would see that we are again logged in to our AWS Management Console. In this step, we created a IAM user and we logged in with the IAM user credentials. And from now on, we'll be using IAM user for performing all our activities with our AWS account. I'll see you in the next step.
Welcome back. Before we get our hands dirty, let's get a 10,000 feet overview of what we would be doing in this specific course. We would be deploying containers using AWS ECS to AWS. We know that AWS is a very popular cloud provider. Now, what is cloud? What is AWS? Why is it popular? What is a container? Why do we need ECS? These are kind of the high-level questions in everybody's mind. If you are already familiar with this, feel free to skip this video and go on to the next one. However, if you want a quick 5-minute overview of all this stuff, go ahead. The most important feature of cloud is on-demand resource provisioning. Let's talk about the good old days where if I need a server, I would need to start planning months ahead. But with the cloud, it's on demand. I need it now. I place a request, I would get the resource. That's the most important feature of the cloud, on demand resource provisioning. Let's think of the use cases. Let's say I'm running an online shopping application. Amazon is a very good example. You know that these applications have varying loads through the year. On the Thanksgiving day, they have very high load, and on other days, maybe it's not as much load. If you have the data center sitting with you, then you need to provision resources that would satisfy the peak load, and rest of the year those resources would be sitting idle. If you use the cloud, then when you have peak load, you provision resources, and as soon as the peak load is over, you would release them. Consider you are a startup. You hope it would be successful, but you don't know how successful it would be. So, should you procure all the resources, have them in a data center, or should you make use of the cloud and provision resources as and when they are needed, as and when you are successful? Cloud is really helpful in a variety of use cases, and that takes us to AWS, Amazon Web Services. AWS is the leading cloud service provider. The other two competitors are Azure, Microsoft Azure, and Google Cloud Provider, or the GCP. AWS is not just the first among them, but continues to be the leader in terms of the variety of services provided. It provides around 90 plus services with a wide variety of features. During the last decade, AWS has established itself as reliable, secure, and also cost effective. We go to cloud for on demand resource provisioning, and AWS is the leading cloud service provider. Now, the next question is, why do we need containers? As we all know, we are heading towards microservices architectures. Instead of building a large monolith, we would build a number of small microservices which talk to each other. And with these microservices, you don't want the deployment of them to be complex. You'd want a simple deployment process. Imagine that your operations team is trying to deploy a application. Let's say it's a Spring application which is built using one of the latest versions of Spring Boot. To deploy that application, let's say you're providing a jar file. What should your operations team do? The first thing they would need to install is the operating system. Let's say you provided an instruction saying Linux operating system. The next thing they would need to install is the software you would need. Let's say you would need Maven, you would need Java. You need to specify which versions. If there is any environment configuration that is needed, you need to specify that. And after that, you need to specify the application configuration. All this stuff is manual. You're providing manual instructions to your operations team saying install this specific version of OS, this specific version of the software, this specific version of the application. And the chances that they make a mistake is very high. And that's where containers come in. With containers, all that you need to do is you'll build a container. The container contains all the things that are needed to run your application. It contains all the software, it contains all the configuration, and it contains your application. So all that you need to tell your environment guy to do is, hey, here is the container, go ahead, run it. And thereby, the chances that your operations team makes a mistake are drastically reduced. The most popular tool to create container images and run them is Docker. If you are new to Docker, I would really recommend you to go to the GitHub repository and watch this video, Docker in 5 steps. It will give you an excellent introduction to the world of Docker and containers. Now, you have a container for each of these microservices. In the microservices world, there are a lot of containers. There are a lot of instances of each containers that are running. Managing them is really difficult. And that's where container orchestrators come into picture. To the container orchestrator, you'd provide the image of a container and you'll provide the configuration. You'd say, I need 5 instances of this container running, and each instance would need 1 gig of memory and 1 virtual CPU. So that's the input that you would give to the container orchestrator, and the container orchestrator would make sure that it deploys everything down to a cluster. The cluster is nothing but a set of virtual servers. In AWS terminology, a virtual server is something called EC2, Elastic Compute Cloud. ECS is nothing but a container orchestrator. ECS stands for Elastic Container Service, Earlier it was called EC2 Container Service, but now it's renamed to Elastic Container Service. And to ECS you provide, okay, I need to run these containers. I need X instances of container A, Y instances of container B, and container A needs this much amount of memory and CPU, container B needs this much amount of memory and CPU. And ECS would make sure that these containers are deployed into a cluster. Cluster is nothing but a set of EC2 instances, a set of virtual servers. There are two variations of ECS, ECS with EC2 instances and something called Fargate. In ECS with EC2 instances, you would need to manage the cluster as well. So you need to say, I need 5 EC2 instances, I need 10 EC2 instances, I need to increase the number of EC2 instances and stuff like that. With ECS using Fargate, you don't really need to worry about what's in the cluster. AWS takes care of it. All that you need to do is provide the container images and configuration, and AWS Fargate would take care of deploying those to your cluster. You don't care what's in the cluster. AWS would take care of that. To summarize, we go to cloud because we would want to get resources on demand. We use AWS because it's one of the leading cloud service providers, as well as it's very, very reliable and offers a number of services. We go to containers because it makes deploying microservices very, very easy. And we use container orchestrators to deploy these containers to clusters. ECS is AWS proprietary implementation of a container orchestrator. It is very, very similar to Kubernetes, which is also a container orchestrator. There are two variations of ECS, ECS with EC2 instances and AWS Fargate. In ECS with EC2 instances, you would manage not only the container and container configuration, but also the cluster. You would manage how many instances are there in the cluster and all that stuff. However, with Fargate, you don't really care about what's in the cluster. You just care about the container image and the container configuration, and AWS would provision the necessary resources, necessary virtual servers to deploy your containers as per your configuration. The idea behind this step was to give you a 10,000 feet overview, and if some terminology was not really clear, that's not a problem at all. Over the course of next few steps, we would discuss each one of these in detail. I'll see you in the next step. Welcome back. Are you ready to deploy your first container to the cloud? If you are, let's get started now. There are two things you need to ensure. Number one, I'm logged in to the AWS Management Console as an IAM user. I'm using the user ID that we created earlier, the IAM user, in 28 minutes _dev. Number two, I am in a specific region called US East North Virginia. Make sure that you are also in this specific region. Those are the two things that you need to ensure before we can get started. In this step, we would want to deploy a sample application using Fargate. How do we do that? Let's get started. Services, type in ECS. I'll click ECS down here. This would launch up the Getting Started wizard, and you can click the Get Started button down here. As you can see in here, the URL shows first run with a capital R. If you don't see the Getting Started wizard, you can also type this URL in. The first run wizard helps us to create something called a container and a task definition. It helps us to define a service. It helps us to define a cluster, finally review it, and then create and deploy our application. There are a lot of things that the first run wizard does automatically. In this step, let's focus on running through the steps and getting them working. And in the subsequent steps, we would try and understand each one of these things in detail. We'll talk in detail about what is a task definition, what is a service, what is a cluster. We'll talk about all that stuff as we go on. For now, let's focus on getting our application running. I'll go further down. The first part is defining a container. I'll use the sample application which is provided by AWS. So I'll leave it at sample app. Next thing that you would need to define is the task definition. So we would want to run a container, and to run a container, we would need to define a task with that specific container. To give it a proper name, I'll click edit. We would be running a sample app as part of this. So I'll say sample app task definition. It's always important to make sure that your task definition has the name of the container in there so that it's easy to understand what the task definition contains. I'll leave the other stuff at defaults and say save. we can click next. We would go on to the service definition screen. A task definition defines what container to run. A service, on the other hand, defines how many tasks to run. Do you want to use a load balancer and all that kind of stuff? So if I want to run 5 instances of the application, I would define it as part of the service. So if I go further down, there's a name given to this service. So it says sample app service. That looks cool. It says number of desired tasks is 1. And for now, because there is just one task running, let's not worry about the application load balancer. Let's just have no load balancers to start off. Let's leave other stuff at defaults and click next. Now we have defined that we would want to run a specific container as part of the task. We would want one instance of that task as part of the service. Now where do we want to run these tasks? We would want to run them in a cluster. Now over here we need to define our cluster. You need to give a name to our cluster. I'll give a generic name to this cluster because we can use this cluster to run any number of services or tasks. So I'll call this AWS Fargate cluster. We'll leave the rest of the stuff at defaults and click next. In the next screen, we can review what we have configured. We have configured a task definition saying we would want to run a container sample app which is provided by AWS. We would want to have one instance and we have named the cluster. There are a few things in here that you might not understand. Don't worry about them. We'll get to them as we progress in this specific course. Now let's go ahead and click the create. You'd see that the creation of everything that we have configured has started. This would take a little while, about 5 minutes I would think. It says up to 10 minutes in here. If you want to grab a coffee, go ahead and get yourself a coffee. In this step, we started deploying our first container using Fargate. We saw that there are a lot of concepts, there are a lot of new terminology that are present as part of this configuration. Don't really worry about them. Let's try and get something working and then we would focus on each of the individual concepts. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we kicked off the deployment of our first container using Fargate. And it took about 5 minutes and the entire 9 of 9 steps of preparing the service is complete. You can see that there are a lot of resources which are being created in here, a cluster, a task definition, a service, and there are other things created in here, a log group. You can see that a cloud formation stack is created and VPC, subnet and security groups. What I've done is I've taken a screenshot of this screen so that we can actually pursue each one of them in the subsequent steps. In this step, let's try and run the application that we have created. What I'll do is I'll say view service. So I'll say view service, and once you do that, this is the page where you can see all the details of the service that we have launched. Over here, there are a number of tabs. What I'll do is I'll go to something called the tasks tab. We said we would want to run one task as part of this service, and that's the reason why you can see that there is one task which is running as part of this service. What I'll do is I'll click the task link. So I'm clicking the task link over here, and once I click the task link, I can see the details of the running task. You can see that the status of this specific thing is running. Over here, what I would want to do is I would want to run the application which is part of that specific task. How can I do that? The way you can do that is you can use the public IP of the task. So I'm going to use the public IP of the task and open a new tab and say Control V. You can see that you are able to see the application up and running. It says Amazon ECS sample app. Congratulations! Your application is now running on a container in Amazon ECS. Isn't this wonderful? Now, you might say, hey Ranga, the application is running. There's a lot of magic happening in the background. I'm not able to understand what is really happening behind the application. We'll start to uncover the magic and look at what's happening in the background in the subsequent steps. So until then, bye-bye. Welcome back. Congratulations on successfully running your first container and launching it up in a browser. In this step, let's focus on understanding a very important concept called task definition. How can you see all the task definitions? The way we can do that is by saying services, go to ECS, and over here you can see the task definitions as the second link. Now, what do you really want to deploy using ECS? We would want to deploy containers. Task definition is the place where you put all the information about your container. So you define what are the different containers that would be part of the task. You define how much resources do each of these containers need, and a lot of other configuration. You can see that there is a task definition which is already created in here. This was created as part of our first run wizard. Now, if you click it, you can see that it takes you to a specific revision of the task definition. The thing is, each time you modify a task definition, you are creating a new revision of that specific task definition. So each task definition has a task definition name and a revision. Now, if I click this revision, you can see that there is a button to enable us to create new revisions, but what we'll do is we'll focus on what is present in here. You can see that there is a little bit of configuration of this task, and down below, if you go further down, is where you have all the container definitions. This is the container which we have launched as part of our sample application. To understand task definition further, let's try and define a new task definition. I'll go back to the task definitions and say create new task definition. The first thing it asks is Fargate or EC2. We'll talk about EC2 versus Fargate a little later. Let's choose Fargate for now and say next step. When you are defining a task, the first thing you need to do is to give the task a name. Typically, you would use the task definition name to kind of give an indication of what it's running. And I think one of the best ways to represent that is by giving the container names. Now, what container do we want to run as part of this task definition? We have already created a container for you. The container is for the Hello World REST API application. The details of the container is present down here. So if you go to the container section, the Hello World is where the detail of this specific container is. This container is actually deployed to something called Docker Hub, which is where we would use it from. As we go further in the course, we will learn how to create containers for your Spring Boot applications and how you can deploy them to something called Docker Hub. What I'll do is to name the task, I'll use the name of the container. So I'll say AWS Hello World REST API. You can either type it in or you can actually paste it from the GitHub repository. The next thing that we would need to configure is something called a task role. Once we configure all the containers, what does ECS need to do? It needs to download the container images from the Docker registries, maybe Docker Hub, maybe the container repository which is provided by AWS itself. Now, to be able to do that, it needs certain permissions. How do we give those permissions? That's by using task role. So I would need to configure ECS task execution role. This role was created by the first run wizard, and it has permissions to be able to go and download your container images. We will leave the rest of the stuff at defaults and move on to something called task size. The task size is a very, very important configuration. A task might be having a number of containers which are running as part of it. The task size defines how much memory and how much CPU you would need. I'll start with configuring 0.5 GB of memory and 0.25 vCPU of CPU. So I'm saying to run the task, we would need half GB of memory and 1/4 of a virtual CPU. The reason I'm choosing a lower amount of memory and lower amount of vCPU is to keep the costs low. We are just trying to learn in here, and lower configuration will allow us to reduce our Fargate bill. Now we can move on to defining our container definition. So I'll say add container. Over here I can define a name for the container, which image, the container image path. What's the path to the container image? We know it, right? So I'll copy this from here, or you can even type it in if you'd want to. Make sure that you actually type the exact one as it is. From here I would pick up the container name and put it down here. So the name of the container is AWS Hello World REST API in 28min AWS Hello World REST API, and the image has the release at the end. The next thing you can configure for a container is an optional configuration called memory limits. Earlier we said the task can have up to half GB of memory, and over here you can define how much memory a task can have multiple containers, and for each of the containers you can specify the limit in here. There are two kinds of limits, a soft limit and a hard limit. A soft limit is how much should ECS reserve for this specific container. So if I specify 100 in here, then what ECS does is it would reserve 100 MB of memory for this specific container. The hard limit, on the other hand, is all about what is the maximum amount of memory that this container can ask for. So if I say a hard limit of 200, that's the maximum that this container can get. If it tries to exceed that limit, then it would be killed. You can read much more about hard limit and soft limit by going over information icon. If you hover over it, you can read this stuff which is present in here. It says, if you specify a hard limit, your container will be killed if it attempts to exceed that limit. If you specify a soft limit, it's also called a memory reservation. ECS reserves that amount of memory for your container. Now, I don't really want to worry about hard limits or soft limits because we are only going to have one container as part of this specific thing. I'll move on to the next important configuration, which is a port mapping. A port mapping specifies what port from the container you'd want to expose to the host. We have created this specific Hello World application to run on port 80. So I would need to configure port 80. I would not want to worry about the rest of the details for now. I'll go ahead and say add. We can also add more containers if you would want to run them as part of the same task. But let's not worry about it right now. Let's have just one container running. Let's take the defaults for the rest of the configuration and say create. In this step, we saw the basics about task definition. We saw that the task definition allows us to define the configuration of the task. One of the important configurations is how much memory and how much CPU does the task need, and it also allows us to define the containers which would be part of the task. Now, we have a task definition, but we would want to run this task. How do we do that? That's what we would explore in the subsequent steps. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we created a task definition. We created a task definition, AWS Hello World REST API. In this step, we would want to be able to run that. How can we do that? We need to understand the concepts of cluster and a service. Let's get started with that right now. Now, I would go to clusters, and once you go to the clusters, you can see that it says Amazon ECS cluster is a regional grouping of one or more container instances where you can run task requests. So basically, cluster is a group of virtual servers, group of EC2 instances where you can run your tasks. We have already created a cluster earlier. The first one wizard created a cluster for us, which is called AWS Fargate cluster. If I go inside that cluster, you can see the running instances of services and tasks. So you can see that in here it says active service count is one Fargate. So we have one Fargate service running and one Fargate task running as well. In the first one wizard, we had actually created a sample app service defining the fact that we would want one instance running. So we said we would want one instance of this task running. Let me expand this a little bit. So we said we would want one instance of sample app task definition running at all points in time. So to be able to run your tasks and manage the running of your task, you need to create something called a service. So let's create a service right now. I'll say create, and the service type that we would want to create is Fargate. Make sure that you are choosing the right task definition. So we would want to use AWS Hello World REST API revision 1. Let's use the latest version of Fargate platform. Make sure that you are choosing the right cluster. That is the one which we created in the first run wizard, AWS Fargate cluster. Now you can give the service a name. Typically, I would actually keep the name of the service and the task definition very similar. So I'll say AWS Hello World REST API service. This would allow us to recognize that this service runs this task definition. For now, let's keep the number of tasks to 1. And rest of the stuff, let's leave it at defaults, and let's do next step. On the next step, we would want to configure the network. The first thing that we would need to select is something called a VPC. VPC stands for Virtual Private Cloud. It is like your own private network in the cloud. This is a screenshot I have taken when the first run wizard completed executing. And over here, you can see that a VPC was created for us, and you can see the VPC ID also present in here. Creating this VPC allows us to protect all the resources in the VPC from anybody outside the VPC. Make sure that you choose the VPC, hovering on which you'd see AWS Fargate cluster. So when I hover over VPC with the ID AA in the last two characters, I can see ECS AWS Fargate cluster in the tip. So I'll choose that VPC because that's the VPC we created and we would want to use it. The next thing which you would need to configure is something called a subnet. A subnet is nothing but a segment of your VPC. You can configure different rules for different segments of the VPC, for different subnets. For example, let's say a subnet contains your web server. People from outside the subnet should be able to access your web server. In that kind of situation, you would create rules to enable public access to that subnet. Let's say a subnet contains your database. For that subnet, you would not need to allow public access. Only your applications should be able to access your database. In that kind of situations, you would restrict access from outside. In that kind of situation, it's called a private subnet. When we ran the first run wizard, it created two subnets for us, subnet 1 and subnet 2. You can choose either of those subnets to run this specific thing. I'll use US East 1A. You can see there's a public subnet 1 which I'm making use of right now. The next thing that you need to configure is something called a security group. A security group is a virtual firewall. It configures what kind of traffic you'd want to allow to your specific task. You can say I would want to allow traffic on this port. Let's do an edit in here. And over here, what you can see is the fact that we are creating a new security group and we are allowing traffic. So we are allowing inbound traffic on port 80. We'll play with security groups a little later. For now, I would leave the default port 80 in there and click save. The next thing you can see in here is whether your task needs a public IP. For now, we would want to actually be able to access the task. So we'll say enabled. Let's not worry about load balancing and health checks for now. Make sure that you turn off service discovery. Later in the course, we'll use service discovery to enable communication between two microservices. For now, let's not worry about it. Make sure that you uncheck this checkbox and click next step. A service can also help you to configure auto scaling rules based on the load that your application is receiving. You can increase the number of tasks, decrease the number of tasks and such stuff. We'll look at auto scaling a little later. For now, let's take the default and say next step. You can review the configuration in the next screen. Make sure that the task definition is AWS Hello World REST API. The service name also matches that, AWS Hello World REST API. Number of tasks is 1 and go ahead and click create service. This would create the service. This would take a little while. What I'll recommend you to do is take a break, take a coffee and come back. In this step, we started creation of a service to be able to run our task. We had to configure a variety of things to get the service up and running. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we created the service. In this step, let's see what's happening behind the background. If I go down in the screen, I can say view service. Over here, I can see the tasks which are running as part of that specific service. So as part of AWS Hello World REST API service, there is one task which is running right now. If I go back to the clusters, you can see that this cluster now has two services and two running tasks. If you don't see two running tasks yet, and if you see just one running task, then probably you need to wait for a little while. If you go into the cluster, you can see the services and you can see how many tasks are running for each of these services. If you see 0 down here, then you need to wait a little while the task comes up. Once you see that there is one running task for it, you can go ahead and click that service. And over here on the inside, you'd be able to see the running task. You can see that as soon as we created a task definition and we created a service, the service ensures that the task is running. When we defined the service, we said we want one instance of this task to be running. And that's what service ensures. It would make sure that one instance of this task is always running. Now let's try to access the REST API which is part of that specific service. I'll click this task. I would need the public IP of that specific task. So this is the public IP of that specific task, and I can take that and type it in. You can see that there is an error which is being thrown out. That's cool. REST API which is exposed is /hello world. If you type in the public IP of the task followed by /hello world, you should see this. There are a couple of other APIs. So hello world bean is a JSON API, so it's returning a proper JSON response. If you don't see the formatted JSON response, maybe you have to install a JSON viewer plugin in your Chrome, but you should see something of this kind. You should see a message coming back. So if you are able to see this, then it means we are able to access the REST API exposed by the task. Let's try a few things right now. Let's go back to the cluster, and over here AWS Fargate cluster, and what I'll do is I'll go to the tasks and try and kill this task. So what I would want to do is try and kill the task which is running. So I'll say AWS Hello World REST API, this task I would want to stop. Let's say due to some accident this container stopped working, and let's say stop and stop. So what is happening now is that container is no longer in the running tasks. When I go to the stop screen, I can see that this task is now being deprovisioned and it's actually being stopped. That's cool. If you wait for a little while and go back to the running tasks, you'd see that a new task was provisioned. So you can see that it's actually showing a status of running. So you'd see that this task is a new task, because if you go there, if you click the task, you can see that this public IP would be different from the earlier public IP which we used. So earlier we used 3.92.62.96. You might have something different, but you'd see that whatever we used earlier is different from what we have right now. And if you execute the URL, you'd still see that the API is working. If the API does not work, make sure that you wait for a couple of minutes and the API should be up and running. So what we saw is that when we kill a task, what's happening? The service is making sure that it launches up another task. Once I specify that I would want one instance of a task running, the service ensures that one instance is running always. If it sees that a task goes down, then it would automatically bring up another new task. Now let's try and have more tasks configured for that specific service. Let's go back to clusters. Let's go back to the specific cluster which we are interested in. Let's go back to the Hello World REST API service and let's click update. So we are trying to update the service. What update do we want to do? We would want to increase the number of tasks to 2. So I would want 2 instances of this task running. I'll say skip to review. I don't really want to configure all the other stuff, and click update service. Now I'll go back to viewing the service. You can see down here that now it says desired count is 2 and running count is 1. So basically what it's saying is we would want 2 tasks running, but currently only 1 task is running. And if you go to the task screen, within a little while you would see that there are 2 tasks of this specific thing running. In a nutshell, the most important thing that you need to remember about a service is your service manages your tasks. You can configure how many tasks you would want to be running, and the service ensures that that many tasks are running at all points. Even if you kill the task, even if some of the tasks fail, even if some of the containers fail, the service would be monitoring that and making sure that a new task is created. In this step, we further understood the concept of a service. Just to quickly review the concepts that we understood until now, a task definition defines what are the containers that should be part of a specific task. A task is a running instance of a task definition. A service helps us to make sure that a certain number of tasks are running at all points in time. I hope you are having a lot of fun, and I'll see you in the next step. Until then, bye-bye. Welcome back. As they say, with great power comes great responsibility. Cloud gives you great power. You can provision powerful resources at a click of the mouse. However, it's your responsibility to know what the cost of the power that cloud is providing you with. In this step, let's look at 5 recommendations to keep your costs as low as possible. Number 1, set billing alerts. If you look at the GitHub repository of the course, there's a video on how you can set billing alerts for your account. Make sure that you set those billing alerts. The second thing that we recommend is for the first week that you are making use of cloud, monitor the billing dashboard every day. Whenever you are accessing the course, the first thing in the day, check your billing dashboard. See if you are getting billed for anything. It's easy to access your billing dashboard. All that you need to do is, I'm logged into the IAM account and I'm trying to access my billing dashboard. It's going there and it says you don't have permission to access the billing information for this account. I'll log out of this account and go to the root account. From the root account, we need to give a permission. Sign out. Sign in again. I want to sign in with root. Let's sign in with the root credentials. Click on in 28 minutes or your name there and click my account. This will open up in a new window, and over here you can search for IAM. This is where you can configure it. You can see IAM user and role access to billing information. You can see that currently the IAM user role access to billing information is deactivated, but because we will be using the IAM role for the most part during the course, we would want to enable access to billing because that would be easy. What you can do is click edit and say activate IAM access and update. Now you can see that IAM role user access to billing information is activated. I'll go to IAM. I'll copy this URL and I'll try to go to the IAM console. Now I'll sign in with the IAM credentials. And let's see if we are able to access the billing dashboard right now. Congratulations! So you are able to now see the billing dashboard, and you should see 0 and 0 in here. Because if you have not really started creating a lot of AWS resources yet, you should see something very, very near to 0 and 0. I am recording this video at the end of the course. So as I was recording the different sections of the course, this is what I was finally billed from AWS for this specific month. As you can see in here, not all resources that we would be using in this specific course are in the free tier. You would be billed for a few of these resources. Let's look at 2 things right now. One is what are the free tier services that we made use of, and the second one is what are we really billed for. Let's start with the free tier services. You can see over here the different services, the free tier usage limit, what is the current usage, and how much percentage of the free tier usage for the month have we consumed. You can see that for RDS there are 2 metrics, 20 GB of database storage and 750 hours of T2 micro instance. And you can see that I have consumed about 60% of both these metrics. If I go above 100%, I'll be billed for these as well. So make sure that you're stopping the databases when you don't need them, and once you finish the course, you terminate the database. Do not worry, we'll have frequent instructions at the end of the sections on what are the resources you might easily clear out. You can also see that I have used about 355 hours of EC2 instances when I'm recording this course. This is about 47% of the free tier usage. We use code build to set up CI and CD, and you can see that I have used about 5% of the free tier. We use EC2 container registry, that is ECR, to store our Docker images, our container images. And you see that I have used about 2% of it. You can see that most of the other usage is almost negligible. Now, I'll go back and look at what have I really been billed for. Let's go to the bill details. You can see that the only real thing that I have really been billed for is EC2 container service. That's ECS. Actually, now it's called Elastic Container Service. Still, in the bill, it shows as EC2 Container Service. And even this says EC2 Container Registry. That's interesting. Now, let's not worry about it. Let's go to US East North Virginia. That's the region which we'll be using throughout the course. You can see that over here, there are 2 important things I have been billed for. One is Fargate, and it says memory. And the other one is again Fargate, and it says vCPU. You can see that I have been billed for memory about 10 cents, for vCPU about 46 cents. We'll be using ECS Fargate as the container orchestrator for deploying our containers. Whenever we define a container, we need to specify the resources that it needs, and we would specify the resources in terms of how much virtual CPU it needs and how much GB of memory it needs. You can see that for the GBs of memory I have been charged 10 cents. And for the CPU resources, I have been charged 46 cents. So when you're using ECS Fargate, remember to keep the number of containers running to as minimum as possible. That would ensure that they consume as less resources as possible and you will be billed less. For most of the other things, we are in the free tier, so we are fine. If you are not in the free tier, then you'd also be billed for the other stuff. That's the second one. Keep monitoring it every day. The third and the most important one is to stop resources when you are not using them. I know we come from a background where we procure the servers, and in our dev environments, QA environments, staging environments, we are not used to stopping them at any point in time. You just keep them running all the time. But that's not how cloud works. Cloud is on demand and you are charged for keeping your resources running. And therefore, you should optimize the use of your resources. So if there are any EC2 instances, if there are any relational databases, if there are any load balancers, anything which is expensive, don't have them running all the time. If you're not using it, just stop it. And that applies to this course as well. If you're doing the course for an hour, at the end of the hour, terminate all environments. Do not leave them running. Cloud is here to stay, and this is a habit we should develop as a responsible cloud developer. The next two things are little hard to do, especially when you're getting started with the cloud. Understanding the free tier, understanding the fact that there is a 12-month limit from the time you created your account to most of the things which are there in the free tier, and understanding how pricing works for different resources. These are little tricky things at the start. These are things you'd learn as you go, but make sure that you access these two resources. The first one is AWS free tier. Just Google for AWS free tier, you'd get onto this page and you can see what are all the things which are part of the free tier. The important thing to understand is there are certain things which are only free for the first 12 months of your account. And other thing is these rules could change anytime. So make sure that you look at the rules, see what are free for 12 months, what are free forever, and make sure that your usage is monitored. Understanding how pricing works for different resources is even more complicated, especially when you're getting started. You can do a Google for AWS pricing and you'd land up on this page, AWS pricing. It's not easy to understand all the pricing because there's a lot of fine print to most of it, but just try to get a high level overview of how pricing works. For example, EC2 instances are built when you keep them running. So the longer you run them, the more they would cost you. Storage might work a little differently. For example, if you take S3, you'd be billed based on how much amount of storage you are making use of, how many gets you are doing, how many puts you are doing, and all that stuff. Just spend some time in here to get used to the whole fact, because these two things are hard to do. Things I would recommend you to do is the first three things. Make sure that you are setting billing alerts, make sure that you are monitoring it every day, and make sure that you are stopping resources when you're not using them. Billing is one of the most difficult topics for somebody who's getting started with the cloud. It's something you'd get used to over a period of time. Make sure that you adhere to the first three rules and you'd see that you do well over a period of time. I'll see you in the next step. Welcome back. In the previous step, we were talking about how you can reduce billing. And one of the important things we said was set billing alerts. In this step, let's look at how you can set billing alerts for your AWS account. I'm logged in with my IAM account in 28minutes_dev. You can actually do these changes with either the root account or the IAM account, but as always, it's recommended to do these kind of stuff with your IAM account. I'll click the link in here and I'll go to my billing dashboard. And over here inside the billing, we can set billing preferences. So what we want to do is we would want to receive a PDF invoice by email. We would want to receive free tier usage alerts, and we would also want to receive billing alerts. So I'll do this and say save preferences. Once you click save preferences, the billing alerts feature is enabled.
But how do we configure the actual billing alert to say, okay, if the billing goes above this amount, I would want to be alerted? How can I configure that? Earlier, there was just one option for doing that. That was called CloudWatch, which is what is redirected by this link. Now, there is a new feature called budgets as well. Either you can click the link here and go to CloudWatch, or we can directly go to CloudWatch from here. So I can type in CloudWatch in services and pick up CloudWatch from here. CloudWatch is basically a monitoring service. So you can monitor the AWS services and trigger alarms when something unexpected happens. For example, if you see that the usage of a specific resource is greater than a specific thing, if CPU is used beyond a certain limit, all that kind of stuff you can actually configure using CloudWatch. For now, let's restrict ourselves to billing. Make sure that you are selecting US East North Virginia as the region. Make sure that you are selecting US East North Virginia, and now you can go ahead and click billing. You can see that you can get 10 free alarms and 1000 free email notifications each month as part of your AWS free tier. So let's go ahead and create the alarm. So when do we want to get the alarm? When the estimated charges over 6 hours is greater than, let's say, 0 USD, and click next. What should happen when it's greater than 0 USD? We would want to actually create a email. So what I'm saying is, SNS is something called simple notification service. This can send an email to us when the CloudWatch alarm is triggered. So when the alarm is triggered, we would want an email to be sent. So I'll say billing CloudWatch alarms topic, and the email ID which I would want the billing alerts to be sent to. I can say create topic. Once you do that, you might need to validate your email address if you get an email on your email box. If you don't, that's fine. All that you need to do next is to go ahead and click next. Now I can give the alarm a name. I'll say billing alert. I'll say next. You can review everything that we have specified in here. So what we are saying is, when estimated charges is greater than 0, send a notification to this specific topic, and that would send us an email. So I'm saying create an alarm, and you'd see that we have successfully created an alarm called billing alert. The other option to create an alert would be to use budgets. So we can use AWS budgets. That's another service which is recently introduced into AWS, which is used to monitor your budgets. Let's create a budget. There are different types of budgets that we can create. Let's only worry about the cost for now. So cost budget, and I'll say monthly cost budget, and let's set a fixed amount of $1. I cannot use 0 in here, so I'll set a fixed amount of $1 as the budget, including everything, and I'll say configure alerts. What do you want to configure as an alert? I'll say send alert based on actual costs when we cross more than 10% of the budgeted amount. So as soon as we are spending more than $0.10, I would want an email to be sent. I'll configure my email ID inventedminutes@gmail.com and say confirm budget. Let's review everything. When actual costs are greater than 0.1, we actually get an email. So let's go ahead and say create. So we created a budget with an alert as well. With any of the cloud providers, it's very, very important that you are on top of billing. That's basically what we are doing. We created a couple of alerts, one using CloudWatch, the other one using the new budgets feature. Both these features, when there is some amount of billing that happens, you will be notified immediately. I'll see you in the next step.
Welcome back. One of the important things that we need to always focus on when we are running something in the cloud is the cost. Running applications in the cloud is not free, and the same is the case when you are using Fargate. So to help us keep the costs low, what we can do is we can make sure that all the services are running the minimum instances that you would need. And because we are just learning, what we'll try and do is, as soon as we create a service and we played around with it sufficiently, what we'll do is we'll make the number of instances 0. So let's go back to our Fargate clusters, and I'll open up these two services in new screens. Let's go to update. and let's reduce the number of tasks to 0. I'll say skip to review and update service. I'll do the same thing in the next tab as well. I'll say update. Now we are working with the Hello World REST API service. So let's wait for the rest of the things to populate. Max number of tasks 0, skip to review, update service. What we are doing is we are saying the service needs to make sure that 0 instances of the tasks are running. So that will help us reduce costs associated with running those tasks. I'll close these two tabs and go back to the original tab and refresh the screen. Cool. Now you can see that the desired task is 0 and the running number of tasks is 0 as well. So if I go to the tasks, I don't see anything running. If we need anything further in the course, what we'll do is we'll increase the number of tasks that are part of the service and start it up for that specific moment. And after we use it, let's try and set it back to 0. So make sure that this is a practice you keep following. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous steps, we created a task definition and then we used a service to launch the tasks. You might be wondering, is using services the only way to launch tasks? The actual answer to that is no. If you go into your cluster, you can see services and over here you can create a new service. And if you go to tasks, you can see that there is a feature in here to run new tasks. So you can directly create a new task as well. What is the difference between running a new task and running it as a service? Let's explore that in this specific step. Let's start with running a new task. Let's say run new task, and over here I'll choose a launch type of Fargate. I'll use a task definition of Hello World REST API. I'll leave rest of the details as they are. We will choose the same cluster VPC that we chose earlier when we were creating the service. I'll choose the one which has AWS Fargate cluster in it. That's cool. And I'll choose US East 1A. That's basically public subnet 1. I'll take the defaults for the rest of the things and I'll say run task. So what we are doing now is we are actually trying to run a task directly without using a service. You can see that the task is being now provisioned and we would want a desired status of running. One interesting thing that you would observe is started by for this is empty. If you look at the started by for the tasks which are stopped, the things which we stopped earlier, you'd see that they are all started by a specific service. So they are all started by some kind of a service because the service was what was launching that specific task. However, this one we are not using a service to launch it, and that's why started by is empty. We have manually started it. If you give it a couple of minutes, you'd see that the status of the task would change to running. And now if I go to the task, I can see the public IP of that specific task and I can use that and say /hello-world-bean and you can see the response which is coming back. So the task is running. If you don't see response coming back, just wait for a couple of minutes and you should be fine. Now this is the way you can launch up a specific task. You might be wondering, what is the difference between launching the task directly versus launching the task as a service? The thing about launching the task directly is the fact that when you kill the task, let's say I go here and I stop the task. I've stopped the task. Once you kill the task is killed. There is nobody monitoring the task and launching a new instance of the task again. So the main difference between running tasks as part of a service versus running tasks directly is the fact that services ensure that a specific number of tasks are always running. So if you say as part of this service I would need 3 tasks running, the service would keep monitoring the health of the task and make sure that that specific task is running. Whereas the tasks are kind of one-time thing. You start it and once it's killed, nobody is looking at it. That's the end of the story. Now you might be wondering what kind of situations you would want to use a task. The best situations for you to use a task is when you'd want to do something in batch. You'd want to run a batch program. In this step, we looked at the primary difference between running a task as part of a service versus running tasks directly. we discovered the fact that running tasks directly is better off for batch programs. In the next step, let's check out a batch program and try and run it as part of our task. I'll see you in the next step. Until then, bye-bye. Welcome back. In this step, we would want to run a simple bash program as a task. What we have done is we have already created a container image for a simple bash program and made it available on our GitHub repository. So this is the simple task which we would want to run as a batch program. Don't really worry about what's the logic behind that specific container. Now I would want to run this task on a cluster. How can I do? What is the first step that I would need to do? Think about it. What is the first thing that I would need to do to be able to run a task? Yes, create a task definition. So let's create a task definition. So create new task definition. I'll use Fargate again. Do next step. And over here, I need to enter the name of the task definition. I've copied the entire image name. So I'll just remove the stuff which we don't need. So AWS Simple Spring Task. That's the name of the task definition. I'll use the same task execution role as earlier. And I'll use as minimum memory as possible. So leave it at the basics. I would need to now add a container. Let's quickly do that. I'll paste the image name that we have copied it earlier, and I'll paste the container name. And I don't really need to worry about the rest of the stuff, and say add. I'll leave the rest of the stuff at defaults and say create. And now I would go back and say view task definition. So now we have the task definition ready. Now I would want to run this task. How can I do that? Go to clusters, go to the cluster, go to the task, and run new task. And over here, I'll choose Fargate, and I'll need to choose the task definition. The task definition which we want to use is simple Spring task. Be very careful with that. So we would need to use AWS Simple Spring Task, the version 1 of that task definition. Rest of the stuff, I'll leave it as default. We would want one tasks. I would choose the right cluster VPC which we have been choosing until now, and choose public subnet 1 to run this task in. Let's configure auto assign public IP as enabled and say run task. Once you click run task, you would see that there is a task which is in a status of provisioning. What I'll do is I'll click on the task ID on the left hand side. So let's click on the task ID on the left hand side, and you can see the details of the task and the status of the task in here. You can see what all containers are part of the task, and also you can see a few more details about the task in here. Let's wait until the status of the task changes. I'll pause the video in here. As you can see, the status has now changed to running. So it's now trying to run that specific task. After a little while, you would see that the status has changed to stopped, and it's trying to deprovision the task. The reason why this task completes execution quickly is because there is nothing that the task really does. It just logs a message to the console, and that's it. Now you might be wondering, how can I access the logs which are behind this? So what I can do is I can go and click this arrow beside the container. And once you click there, then you would see a link in here to view logs in CloudWatch. CloudWatch is a very, very important AWS tool. It helps you to monitor AWS resources. You can use CloudWatch to check whether something is running or not. And CloudWatch also has this feature of CloudWatch logs. So all the logs from applications we can directly stream to CloudWatch. When we started running the first run wizard, there was a log group which was created. Similar to this, for every task definition that we have created until now, we have configured an automatic log group. All the logs from this specific task are streamed to this specific log group. Let's see the logs in there. How can we do that? We can click view logs in CloudWatch. This would open up a new window where you can actually see the logs from that specific application. When you go there, you can see that all the logs are present down here. So all the logs from that specific application are present in here. As you can see, the application does nothing. It prints a few environment variables which are configured. It prints all the details about the environment configuration, and at the end it just does a print of do a one-time task in here. A little later we'll look at the code behind this task and how you can actually generate a container and push it to the Docker registry. The important thing to note is the fact that this is a simple bash application. It does something and it quits, and that's the best kind of scenarios where you would go for a task. So let's close this window and get back to our cluster, and let's do a quick summary of what we have discussed until now. So we use services to run long running applications. You have a web application which you need to keep running for a long time. Let's say you would want 3 instances of that web application running. So what you do is you would create a task definition for that, and you would create a service defining that I would want 3 instances of that specific task definition, and the service would make sure that those 3 instances of that web application keep running all the time. So even if one of the instances crashes, the service would make sure that you would start a new instance. You'd use run new task or directly create a task using a task definition if you want to run some batch application. So I would want to do a sequence of steps and exit. I would want to run a program which runs for typically like a few seconds or a few minutes and exit. That's the kind of places where you would actually run tasks. The interesting thing is that there is a feature called scheduled tasks. So you can even schedule tasks, the same UI as a task, but the only difference would be a schedule rule. So you can either say, I would want to run this task every 24 hours, every 2 hours, or every 5 days, or something of that kind. Or you can configure a cron expression. You can say, I would want to run this task at 8:45 a.m. every day. You can do things like that as well. I'm sure you're having a lot of fun with task definitions, tasks, cluster, service, and all these interesting ECS concepts. I'll see you in the next step. Until then, bye. Welcome back. In the previous section, we deployed a couple of simple services, simple containers using AWS Fargate. We learned the basics of what is a cluster, what is a task definition, what is a service, and we learned what is the difference between running a task as part of a service versus running a task directly. One of the things that we observed is on a number of screens, we see something called EC2. Over here, I'm inside the cluster and I see 0 Fargate, 0 EC2 pending tasks, running tasks as well the same. Active services, there are 2 Fargate services and 0 EC2 services. And when I go to create, I'm trying to create a service, and you can see that there is a launch type of Fargate and EC2. Until now, we have been using Fargate. Now, what is EC2? What happens when you launch ECS with EC2 instances? What is the difference between EC2 and Fargate? That's what we would want to explore in this specific section. And as usual, we'll take a hands-on route to discover the differences. Now, what is EC2? If you're familiar with Amazon Web Services, then you know that EC2 refers to virtual servers. You want to run applications in the cloud. Where do the applications run? They're on servers. However, these servers are in the cloud, so these are called virtual servers. And in AWS terminology, a virtual server is nothing but EC2. EC2 stands for Elastic Compute Cloud. Typically, whenever you would want to run an application in AWS, the first thing you would need to launch is a EC2 instance. How can you see the EC2 instances that are present? Let's cancel this and go to services and type in EC2. EC2 virtual servers in the cloud. When I click this, you can see that there are 0 running EC2 instances. When I click that, you can see that there is no EC2 instances which are running right now. If you go to ECS and change the cluster configuration, actually I would want to change the service. So let's say sample app service. I would want to change this service. So this is something which we are running using Fargate. So this one, I would want to say, I would want to increase the number of tasks to 1. I'll say skip to review and update service. What would this do? This would start launching a task of that particular service. So you can see if I go to tasks, not yet, not so fast. If you give a minute and then go to tasks, you can see that now a task is being provisioned. If you wait for a minute or so, you'd see a running status for that specific task. That's cool. Now I'll go to services, EC2 again. So we have a task running. Where is that task running? Oops, there is no EC2 instance that is associated with it. If we go to EC2, still we don't really have a EC2 instance running. That's something you would need to remember. Whenever we are using Fargate, we don't really have access to the EC2 instances or the virtual servers where the tasks are running on. Now, you might be wondering, how is ECS with EC2 different? Let's look at that in the subsequent steps. Until then, bye-bye. Welcome back. Starting this step, let's focus on deploying our containers to ECS running with EC2 instances. Make sure that we are in the region North Virginia. So we are in US East North Virginia, and I'm going down to the usual stuff, the ECS. Right now, I have one running task in the cluster, which is unnecessarily running. As an exercise, make sure that all your services are configured to run 0 tasks. Now, we would want to focus on creating a ECS with EC2 instances. And for this one, we will take a manual approach. Earlier, we created the first cluster, first task definition, and the first service using the first run wizard. Now, we would create the cluster manually. Let's start with it. So let's say create cluster, and over here, you have 3 options, right? The first one is powered by AWS Fargate. This was what the first run wizard made use of. So if you do select this and do next step, over here, you do not have any configuration of EC2 instances. So all that you need to configure is the cluster name, and if you have to create a new VPC, and that's it. However, if I do previous and I choose the second one is EC2 Linux plus networking. In this course, we will be focusing on EC2 Linux and will not be using EC2 Windows. EC2 Windows creates virtual servers on Windows. EC2 Linux creates virtual servers on Linux boxes. So we are going to use EC2 Linux plus networking, and once you do next step, you'd see that along with the cluster details, it would ask you for EC2 instance details as well. That's a major difference between creating a cluster for Fargate compared to creating a cluster for EC2. Now, this cluster, I'll call this as EC2 cluster. And when it comes to your virtual servers, EC2 instances, you can actually ask for it in 2 different ways. This is what is called the provisioning model, where it says on-demand instance or spot. As it says in here, on-demand instances, you pay for compute capacity by the hour. There is a fixed rate that you would pay for on-demand instances. So as soon as you ask for an instance, you would get it, and there is a fixed rate for it. However, with the spot instances, this is more like a eBay, where you bid for it. If you go to spot, you'd see that a number of other options open up. So you can see that you can specify what amount of price you would want to bid and all that stuff. Let's not get into those complexities right now. Let's use on-demand instances. So as soon as you ask for it, you get an instance and you pay a fixed price for it. Now, the next thing it asks for is EC2 instance type. There are a wide variety of virtual server instances that AWS provides, and if you do a Google for EC2 instance type, then you'd land up on this page. So you can see that there are wide variety of images: A1, T3, T3A, T2, T5, M5A, M4. I mean, there are, if you go to these tabs, you'd see other instances as well. Each of these instance types are designed for specific kind of applications, and each of these have different amount of virtual CPUs, different amount of memory, different types of storage, and different kinds of network performance. If you go to T2, there is something called T2 Micro. This one comes with 1 virtual CPU and 1 gig of memory. If you are within the free tier, then T2 Micro is a great thing to use, because you would get 750 hours of T2 Micro free per month. So let's use T2 Micro. Oops, it was a little difficult making the choice, but finally I was able to find T2 Micro, and T2 Micro is now selected. Let's ask for 3 instances of T2 Micro. I'll leave rest of the details as they are. Let's go ahead and say create. So what this would do is this would create a cluster with 3 EC2 instances. So you can see that we are directly creating a cluster with EC2 instances, and later when we define the tasks, you would see that these tasks would be placed on these EC2 instances. One of the interesting things is the fact that because we are creating virtual servers, we are creating EC2 instances. This would take a little bit of time. We are creating 3 T2 micro EC2 instances. It would take a little bit of time, and I'll see you in the next step. Until then, bye-bye.